All right, even. So we have been solving equations this whole unit long. We've done one-step equations, two-step equations, multi-step equations. We solved for just variables, and now it's time to solve for absolute value equations, all right? So your learning target is I can solve equations in one variable that have absolute value in the expression, okay? So let's get going here on these notes. All right, so we're going to first define what absolute value really is. And what absolute value is it's the distance. The distance a number is from 0. And I think you guys will remember that when we talk about absolute value and distance, distance can't be a negative value because there is no, I was walking and I walked back 3 feet. Or negative 3 feet. No, you still walked 3 feet. The distance was still 3 feet. You just walked in the opposite direction, right? So distance can't be negative, but it is a number. The absolute value is the distance a number is from 0. So essentially we can't have a negative absolute value. So if we have the absolute value, that's what these bars are, of negative 5, that means the absolute value of that is a positive 5. We have the absolute value of a positive 5. The distance away from 0 is a positive 5 still. It's still going to stay positive. And we can see that if we mark where negative 5 is here on the number line, and we try to mark how far away from 0 that is, that would be 1, 2, 3, 4, 5 places. There's 5 units away from 0. Same goes for 5. Mark 5 here. We want to find what is our distance away from 0. Again, 0, 1, 2, 3, 4, 5. We're still 5 units away when we're talking about the distance away a number is from 0. All right, so let's talk about this key concept here. How do we go about solving equations, absolute value equations? And the very first thing that we want to do when we're doing this is to isolate isolate the absolute value on one side of the equation. So we need to get absolute value, whatever we have in terms of absolute value, we want that by itself on one side of the equation. Either side, but just by itself, no other numbers around it. The second thing we need to do is set the absolute value equal to its positive outcome. And solve. That essentially means that we've got, okay, this is going to be the answer, the absolute value of this equals some positive number, okay? The third step then is to set the absolute value equal to its negative outcome and solve again. All right, example 1 says to solve each equation. We've got this first one, x, the absolute value of x equals 12. So we need to rewrite that. We actually already have the absolute values by itself, so step 1 is done. Step 2, we need to set it equal to its positive outcome. So we can drop those absolute value bars and set it to the positive outcome, which is just 12, just exactly what it was. And the other way is to set that absolute value x equal to its negative outcome, which is negative 12, right? Okay. Now we just go about solving. We've already solved for the variable then, though, so we get x is equal to 12 or x is equal to negative 12. And we can see that we're right, that if we were to plug these two numbers into the absolute value of x equals 12, into that equation, we'd get 12 equals 12, and the absolute value of negative 12 is positive 12 equals 12 again. Okay, so now b is the same type of thing, except we do have to take step 1. We got to get rid of this 3 here that's next to the x plus 7. And technically what this is doing is this is saying 3 times whatever's inside the absolute value. So that means we have to do the opposite of multiplication, which is division. So we're going to divide by 3 on both sides. And we end up getting these to cancel out. We're left with just the absolute value of x plus 7 equals 24 divided by 3, which is 8. Oop, forgot my other bar. Okay, now we go ahead and start step 2, and we write two equations. We write this x plus 7 equals a positive 8, and x plus 7 equals a negative 8. Now solve. We'll solve this one first. We've got to get rid of that positive 7. The opposite of addition is subtraction, so we subtract by 7 on both sides. We end up getting x is equal to 8 minus 7 is 1. And on this side, we have x plus 7 equals negative 8. Subtract by 7 on both sides. A negative 8 minus 7 is a negative 15. We box our answer here. Those are our two answers in order to make this this original equation a true statement. Okay, if we plug this back in, 1 plus 7 is 8. 8 times 3 is 24. Or negative 15 plus 7 is a negative 8. And the absolute value of negative 8 is positive 8. So 3 times 8 is 24. Okay, so those two values work in order to make this a true statement. Alright, sometimes things don't work exactly like we want them to though, and we'll see that here in example 2. We've got the equation x plus 2, the absolute value of x plus 2, minus 8 equals a negative 8. Okay, and we're going to go ahead and start solving that here. First we need to get rid of anything not next to the absolute value sign, so we're going to add 8 to both sides. We end up getting the absolute value of x plus 2 is equal to 0. Okay. Now we can drop that the absolute value symbol there. We've got x plus 2. We're going to set that to the positive value of 0, and we're going to set that to the negative value of 0. But if we try to do that, 0 is just 0. 0 is no negative 0. It's still going to be 0. So what ends up happening here is that we actually only have one solution to this problem. So we just solve this one, subtract 2 from both sides, and we end up getting x is equal to negative 2. And that is the only solution. Only solution. Okay. Now let's take a look at this next one here. We've got 0 equals 3 plus the absolute value of x plus 4. And remember, our first step says that we have to get the absolute value by itself. So we need to subtract by 3 because that's a positive 3 from both sides of the equation. These will just cancel out. I'll be left with the absolute value of x plus 4 equals a negative 3. And if we stop right there, what do you guys notice? What does the absolute value always tell us about a certain equation? It tells us that it is the distance a number is from 0, and distance cannot be negative. So because it's saying the absolute value of x plus 4 is equal to a negative number, that cannot be true. Therefore, this has to be a no solution. Because there is no real numbers that will make this solution actually true, because absolute value cannot be negative. Alright, example 3 says a support beam for a building must be 3.5 meters long. Okay, I'm going to go ahead and underline that piece of information right there, because I know that when we're talking about some sort of a distance for, the support beam, I mean, it's an important number. It's pretty obvious there. It is acceptable for the beam to differ from the ideal weight by 0.003 meters. We need to write and solve an absolute value equation to find the minimum and maximum acceptable lengths for this beam. Okay, so the beam is supposed to be 3.5 meters in length. We know that it can differ by a little bit, in that differing length that we don't know, we can use the value or the variable x to identify that number that we're not quite sure how far away it is. Okay. Now we have to, in order to figure out how far or how big this could be, the two different lengths that it could be, we could subtract this from the actual value, right? And we know that the absolute value of these two numbers has to be 0.03. It cannot be anything bigger than that. And if we do this, if we solve this equation here, this will give us how the different values of x in order to make this a true statement. All right, so let's go ahead and do that. We're going to drop the absolute value signs and set it to its positive and negative values. We have positive 0.003. And then on this other side, we have x minus 3.5 again, this time equal to its negative 0.003. All right, so let's go ahead and solve this. We're gonna solve for x, and we have x minus 3.5, so we have to do the opposite of subtraction, which is just addition. So add 3.5, and remember, when you're adding a decimal, you have to keep your place values lined up. So where the decimals are, everything has to stay the same. So we have 500 now. Negative 3.5 plus 3.5 is just 0, so we have x, that's it. And then let's add these up. We have 3 plus 0, which is 3. 0 plus 0 is 0. 0 plus 5 is 5. Keep our decimal point, and 0 plus 3 is 3. So therefore, x, the distance, the furthest, the maximum it could be is 3.503 meters in length. Anything longer than that, and it's not gonna be an acceptable length for the support beam. Okay, let's solve this other one now. We got to add 3.5 again to both sides. 0, 0. Adding that here, we get negative 3.5 plus 3.5 is just 0, so we're left with x. And then we have negative 0.003 plus 3.5. Okay, and this gets a little confusing. Remember, though, that the commutative property of addition says the order in which you add things doesn't matter. So what we can actually do is we could rewrite this. I'm going to go ahead and rewrite this up here as 3.500 plus a negative, which is just subtracting 0.003. Okay, that is the same exact thing here. What we've done is we've just switched them, switched the order of them. Okay. So let's go ahead and subtract these. 0 minus 3, we can't do that, so we have to borrow. Can't borrow from the 0, so we borrow from the 5, which is 4. Get out your 10. Now make it a 9. Now we have 10. 10 minus 3 is 7. 9 minus 0 is 9. 4 minus 0 is 4. Put our decimal, and 3 minus 0 is 3. So we end up getting the x is equal to 3.497 meters. That is the minimum value that this support beam could be in length. Okay, so these are the two different values. Could be either one of those. Again, on that last one, just if it gets confusing here, you could always take out your friend and say, hi friend, and then put negative 0.003 plus 3.5. Press enter, and you'll get 3.497, which is the exact same thing that we got. Okay, that's it. That's all we're doing for today. Hope you enjoyed it, and we'll see you next time.